All right, today we'll be covering queries and foreign databases. So in the first part of our lecture, we'll be covering how to familiarize ourselves with databases, comment, read them, add them, or write them, analyze data relationships, one-to-one, many-to-one, or many-to-many, and analyze, add, and test data constraints to ensure you understand them. For our queries part of our lecture, we'll be covering one, how to create an index and analyze every single one of those indexes to make sure that we're getting good efficient data back. So there is a command called explain analyze that will break down the query, show us its efficiency in comparison to a command where we didn't have the index. Then we'll go over the basic functionalities of the different queries: count, sum, average, as, alias. We likely won't cover the indexes and explain analyze until after we cover where, since we need where to be able to analyze, to be able to break this information down. So we'll bring that down over to where. We'll cover the like, in arguments. Then we'll start covering limits, order by, group by, the descending argument. And finally, for the end of the day, we will cover joins, full joins, left joins, and right joins. Does anyone have any questions over the topics that will be covered today? All right, it seems like there are no questions. Friendly reminder, if you have any questions that you want to post on the chat, please post on the Whiskey Questions channel. Other than that, let's go ahead and continue moving forward with our lecture. So the first one we'll cover will be familiarizing yourself with a foreign database, best practices and common pitfalls. So exploring the database structure. So here shows us a bit of a way that we could add some comments into our schema. I've actually never added a comment like this before into a schema. I usually just do the dash dash and I put my comment. I'm wondering what this is actually going to do. So here's our database here. This database was provided to us. Everything has already been created. And I don't necessarily know exactly what's going on here. All I know is that I'm working within a car shop. There seems to be some departments that carry some relationships, some employees that do not carry relationships. And I can tell it doesn't carry relationships because it doesn't have cascade in it. We have some services that carry relationships, some driver that carry relationships, cars that carry relationships. What else we got here? We got a plates, car services, and it looks like this has a many-to-many relationship here, from what I can see. And it looks like that would be it. So that's going to be my car shop. I can take a look at some data as well. It looks like I was provided data for every single one of these. If I open up the car service, well, I can see that there's the many-to-many relationship. If I open up the car's pretty straightforward, except for this driver part. So it looks like this driver part is aiming towards a specific driver. And I'm actually wondering if that's going to be a many-to-one or many-to-many. Let's take a look here. So if that's the wrong one. So if I take a look at cars, so here we have Toyota Camry belonging to driver one, and here we have Honda Accord belonging to driver one. So it looks like this is a many-to-one relationship. Let me take a look at the driver CSV here. Yep, there's no relationship going backwards, so it looks like that's going to be it. We have our cars that are going to be many-to-one relationship to a driver. We have these departments that employees can relate to. And if I take a look at employees, there we can see the department ID that they belong to. Although I don't have that much data, I'm going to go ahead and make the assumption that this is where there's many employees relating to one department. And then we have our plates. Sorry, does someone have something to say? Or is this just a hot mic? Oh, hot mic. All right. Perfect. So now I got all my relationships planned out in my head. I can somewhat understand how those relationships are happening. But I'm still just looking at department. I have no idea what department really is because there was never a comment that was added in there. All right, so let's take a look at department CSV, and we can see that it has mechanical, electrical, or body shop. Those are the three entries that have been accustomed in there. And all I can see in department is that we have an ID and a department name. Okay, well, before we start making any changes to the database, one thing to annotate is, hey, there's no comments here that actually describe what's going on each individual table. This table is missing some content so that other people can just automatically pick up the schema and read it. And after one glance say, okay, well, I got somewhat a better understanding of what I'm working with. I can go into drawing out the schema myself so that I can confirm that it's working well. But currently we're not at that point, right? This is very basic what they gave us. It doesn't, as I can see, my department name doesn't have any sort of check constraint to ensure that the format falls in correctly. If I take a look at the departments, we can see that they're all in title format, but that's not what I see here. All right. So let's continue moving on into our exploring the database portion here. So we have comments that we just went there. A bad practice is to neglect comments in the documentation of data elements, which we just saw. Then we have querying the database to be able to understand it better. We're going to save this point until after we draw the schema and add comments and all the good stuff, just so that we can query the database at the same time we're learning our different types of queries. And now, analyzing data relationships, which we just covered. We went through each one of the CSV files to understand those relationships, whether they were many-to-many, one-to-one, or many-to-one. And then ensuring data integrity, which is making sure that constraints are applied and that they actually meet the requirements. Monitoring performance, which we'll go into the explain analyze here after going into queries. So now that we looked at all of these good and bad practices, we can take a look at our SQL file and realize that it's missing quite a bit of content within it. It's very basic and it's not necessarily doing the job that I needed to do. All right. For example, department name, it gives me a var chart of 50, but there's nothing that says that the department name will actually meet some sort of title requirement. So let's write that in there. We've already covered this, so I'm going to ask for the class to help me out. We have our arguments here. We want to make sure that it's not null, that it's unique. And then I want to add a check constraint that's going to check that the department ID, or sorry, department name meets some sort of regex. We went over this yesterday. Does anybody want to take a stab at building this regex here on line 8? For a title format? Go ahead, Brian.
Let's see. So if we want to do title, we can say let's see, like what's the bracket? Like shift 6, like the upwards caret to get like the beginning of the string. And then opening square bracket, and then capital A to Z. And that right there by itself, I think, should enforce. Actually, no, I'm sorry. Then after that, we can do another, capital A to Z, lowercase a to Z.
Okay. I think at this point we would just want to do lowercase az, but yeah, let's try capital AZ, lowercase a through Z.
And if there's a department name with like multiple words in it, like IT space department, you know, the D in the second, you know, department might be capitalized. You might have like a /s in there to escape any space characters you want.
So /s in here?
Yes, sir.
Okay. Nice. And then let's just do our plus and money. I believe that's correct, right? Our first letter will be within A through Z. any following words will have maybe capital letters, mostly lowercase. I think we wanna, I'm not sure about this capital letters here. Let's actually try it out. Let's see what happens if we try to run this document here. And I'm actually just gonna concentrate on the very first one. Let's make sure that my database is clear. So I'm gonna go ahead and enter car shop DB. And from there, I'm gonna take a look at relationships. Okay, so I have no relationships. I'm about to load my very first table. And I see a question from Will. Go ahead, Will.
Yeah, for regex for SQL, are there any flags like global and like what's the capitalized one? I.
I think you're trying to compare it to JavaScript.
I
that-
can take that actually. There is a case insensitive flag. If you add an asterisk after your tilde, that's a case insensitive match, but there is no global flag. I was looking for that.
Okay, gotcha.
And
friend,
just to clarify, you were comparing that from the JavaScript regex. Is that correct?
Yeah, correct.
Okay, awesome. Go ahead, Will.
sorry, Francisco, the regex on line 8, there's a couple extra enclosing square brackets that might do something weird there. Yeah, thanks.
Okay, awesome. Let's try it out. Let's see. So we have our department. It's only taking mechanical, and let's test it out by making one that doesn't fit our schema. This failed. Okay, I'm gonna go ahead and back out from here. I'm within my example. So I'm just gonna go into car shop DB and run my car shop SQL file. Okay, so I get my notice that the department does not exist, so it's skipping the drop table command. It creates the table, and then it finds the error saying department violates check constraint, department name check, failing bro for this fail. All right, now let's try it this way where we check that the T and capital H will also fail. Okay, well, that didn't fail. All right, we saw that was able to run through. It accepted the first T, but then it didn't fail afterwards. And I believe that that's because of this capital A through Z here. So let's try to remove that, run that again. Okay, so now we get a failure and new row relationship department, body shop. Interesting. So it looks like that A through Z may be required. Maybe we have to do a little bit of experimenting with regex on the side. But if I take a look here, I can go ahead and run this. This will be accepted. It's almost to title format. I just need to make sure that it's able to make sure to not allow for another capital H. It's accepting it as of now. So let's go ahead and ask our good old AI friend here what we can. So let's go over to OpenAI. Let's go ahead and ask it to provide a command. So let's say utilizing SQL, write a regex that will only accept string. Let's just say varchar. Oh, hello. That follows Python's title format. All right, it's a little slow, but it's going through it. Okay, so there's our regex here. I'm gonna go ahead and take that regex. Bring it over to my file. And I'll try it out. See what it does. Okay, so now I get that this fail with the capital H. If I take a look here and I make this just a lowercase h, it's able to take in the format. It looks like that's actually doing what we want it to do. So I don't just want to copy and paste things over to my file. I want to make sure I understand it. So we see that the caret asserts the start of the string. The A through Z matches any uppercase letters. So we see the A through Z there. And then we see that the A through Z with an asterisk matches 0 or more lowercase letters. Okay. Great. So that's matching A through Z, A through Z. Now this parentheses with the same regex inside of it, I'm unfamiliar with, so I want to make sure that I can understand it. So it matches 0 or more occurrences of a space followed by any uppercase letter and 0 or more lowercase letters. I see. So this is happening for every repetitive word. It's making sure that if there is a space after the very first entry, that it can match the first letter being a capital one and all the following ones being a lowercase letter with more than one match. And then it's taking this entire little piece of regex and taking it for more than one match. And then finally, the $ asserts the end of the string. Okay. So now I was able to break down this regex. Well, not me, but ChatGPT was able to provide a regex for us that we can utilize that now we have for title format. And it's able to take it in and ensure that everything's working correctly. All right. So our department store is working pretty well now. We have a serial primary key. Our department name has the correct variable character that we want it to be. It is unique, so we know there's not more than one entry. There shouldn't be any null entries. And we have a check for our data types. Okay, great. So now let's go ahead and add a comment. And from what I saw here, there seems to be a specific way to adding a comment into our actual table. So comment on table. Let's try this out. Let's say comment on table. We want to make this the department is, and now we can add a small comment describing our department. So let's check out what the departments we are that we have. We currently have mechanical, electrical, or body shop. So this should reflect a different. Let me go ahead and option Z this. Departments within the store, i.e. body shop, electrical, etc. Okay, it's expecting a semicolon at the very end of that. And now if I run this, we can see everything was entered, but now we got this comment that was also entered. Okay, let's check what's happening here. Let's run a /d for, oh, I am not within SQL. I apologize. Let's go ahead and go into our car shop DB. Let's run our relationships. Here we have a department and a department ID. All right, let's select all from department. Okay, and we can see the department has come in. Oh, but where did that comment go? I wonder. Huh. We have to figure out a way to grab that comment. Let's check it out. The comment. Oh, there we go. was added to my data table. How do I grab that comment through SQL queries? Okay, so now we see that AI is working through it. It's trying to explain to me what's going on with comments. And now it's telling me that it depends on the table itself. So it tells me to select the table itself here. And the table name. Oh no, object description. That's the actual command, is object description. And then I added the table name with reg class. I don't think that's correct. Let's try to ask Google instead. Okay, so here we can see comments can be viewed using PSQL's \D. Family of commands, other user interfaces might be good. Well, it looks like there's an object name that's being provided here as well. Well, let's try it out. Description, and then it wants my table name, which in this case, it should be department. We'll have to figure out this common part out. Or I'll have to figure it out and reach out to you guys all during part 2. But we can see how we were able to add a comment. That comment lives within my database and it's being managed somewhere else that I need to figure out where to pull it from. And then after that, we were able to copy all of our CSV data and save it correctly into our database. Okay, awesome. The next part is going to be our employees. So let's go ahead and uncomment our employees here. Let's take a look at what we have. We have our ID serial primary key. We have our salary that checks that it's greater than 0. First name, last name, and department ID. Okay, awesome. Our department ID gets made. We have a foreign key constraint on department ID that references the department ID. And then we have a check for the middle initial, where if it is null, or the length of middle initial is equal to 1. All right. Okay, so I'm only accepting null or that the middle initial is equal to 1 within my database entry here. What other checks could I add to my employee table? Go ahead, Sal.
You could also make the first and last name title format or capitalized.
All right, so let's go ahead and make sure that the first name will be capitalized. So I'm gonna go ahead and add my caret for the beginning of the string. I'm gonna make sure that is A through Z. And I'm gonna make sure that it is A through Z as well, with a star for 0 or 1 count, right? Okay. And then after that, I believe it should just be money sign there. I may be wrong about that, but let's try that out. Okay, let's take a look at our data here. Let's open up our employees. Our employees currently have this data within them. Oh. I'm gonna make it entry 4. Robert. He's gonna have a lowercase letter. And let's give him the same department ID. Okay, so now let's run this query here. All right, and we run into a couple of issues, it looks like. So employees does not exist, skipping creates the table. And we run into an issue on number 4, where it does not match the check for the first name. All right, so the check didn't match. Let's go ahead and make Robert into the check. That worked correctly. Let's capitalize the O. That fails because it doesn't accept for that information. And if I make it back to a lowercase letter, we can see that that's going to work. All right, so there's our check for first name. We could probably just add the same exact check to our last name. And we can add one more check to our middle init. Let's go ahead and make a check here. We know that we are accepting null. And actually, instead of adding it there, since we are accepting null, we can add it down here. So middle initial is null, or the length is equal to 1. And now I can go ahead and make a parentheses here. And with that parentheses, I can add an and statement. Where this and statement also makes sure that middle init is a capital letter. Now, if we run that through, we get one failure from Robert because he has a lowercase a. If I make it a capital letter and I run it, everything runs correctly. All my checks are built in and my employee is good to go as far as data constraints. Does anyone have any questions about the employee table? Okay, it doesn't look like there are any questions, but Jose did share something on the chat for us to be able to grab the description. That I'll have to look at, and then we'll talk about that later on. So DJ has a question. Is the length check necessary because character 1 will prevent it from having more than one character? Yeah, that's a great question. For DJ, we definitely do not need this link check. At least I don't think so. Let's go ahead and remove it and let's try it out. Let's say we remove that check. We only have our initial one and we just added one, making sure that it is a capital letter. Okay. Well, what happens if I run AB? Okay, so it tells me that I was able to copy almost everything except for line 5, where value was too long for type character 1. Column middle init AB. Great. So now we know that we don't need that length. We could just run it and let the character 1 be able to handle the length of it. All right, perfect. There are no other questions. There's still a considerable amount of tables that we can do this to. Me going through it might be a little bit more boring than necessary. So let's go ahead and have the class guide me through this process. So I'm gonna go ahead and uncomment here our table for services. And I'll just start calling on people to walk me through what we can do, add to our constraints, or how we can comment this individual information. Terrence, what do you think we should add to services?
Sorry, I'm just looking over it right now. Would we want to add a comment just talking about what the table does?
Okay, we could definitely do that. So let's go ahead and add a comment. I'm gonna grab that syntax of comment on table and then is. All right. So here we have our services. Let's add a comment. All right, and then what would you want to add for this comment? Let me bring up the services CSV file so you could see the data. So here are the services provided. What would you like to place here?
We could just say that this table describes a list of services along with their prices.
Okay. So there we have our comment for this table. Now, regarding the name of service or the price, is there anything that you feel like we should change if we take a look at our CSV data?
Oops. Can you go back to the SQL file?
Of course.
Would we want to take the price, yeah, the decimal down so that the 7 is replaced with a? It looked like none of the prices were over 4 digits.
Okay, perfect. Yeah, let's go ahead and change that. Let's make that into 4 digits.
And I don't check price. What was the highest price on there, if you don't mind me asking?
Looks like the highest price is $79.99 and the lowest is $19.99.
Yeah, so we could just change that so that price is greater than or equal to, you said $19.99?
Right.
And then less than or equal to $79.99?
Okay. Awesome. So now we have our price limits for the data that we're going to be taking in. It's important to note that if this shop grows and it starts taking in other sorts of services, we would have to run an alter table to change that check constraint. But this is good so far. All right. And what about our name of service? Is there a specific data entry format that we're accepting?
Looks like it's, unless I'm, let me see, unique, not null. I'll change the brick expansion. I don't, I'm not sure exactly what you might be trying to point out. Sorry.
Yeah, no problem at all. Let's go ahead and add a check constraint to make sure that everything is within our title format again. So,
okay. Sorry about that.
No problem. Name of service, we're gonna go ahead and provide our string. That string checks for A through Z. And then it checks for A through Z a countless amount of times. Okay. Then we also wanted to check if there is, again, an A through Z instance, what they following A through lowercase z, so that's accepting title format countless times. and countless repetitions. And finally, we want to symbolize the end of the string.
Francisco, I believe one of the services was a tune-up with a hyphen, so you're going to want to add a escaping hyphen into that.
Nice. Okay, so let's add an escaping hyphen. And that escaping hyphen should be here, if I am correct, which I believe goes like this. Is that right? Or is it this way?
Should just be 1/, I believe.
All right, let's try it out. Say we run it, we get a problem with oil change. It seems like oil change doesn't meet our service name constraint. Okay, I wasn't expecting that, so I probably made a mistake within the regex. I'm gonna go ahead and take a look at what I had before. I'm gonna copy it, bring it down and compare it so that I can see where I made my mistake. Go ahead, DJ.
You're checking for 2 spaces. Right after your asterisk, that group, the parentheses group, needs to be butted right up against the asterisk there.
Perfect. Thank you so much. All right. So we can see that, and if I run it now, we still have that same error. Likely because of the same spacing towards the end. All right, so there we have our error one more time. Again, I'm going to bring this down and compare it just in case I'm making a silly error. Let's go over again. We'll paste it. We can see it's almost exactly the same thing, with the difference being this hyphen. So it looks like I need to add this special character somewhere, and likely not in there.
Would the hyphen go inside the lowercase a to z that's inside of the parentheses?
Yeah, let's try that out.
To-
Let's try a hyphen.
Or I was looking on the one on the inside there, yeah.
Yeah. Okay. Now we run it. Okay, so now it was able to accept the correct things, except for engine oil tune or for engine tune. So now it's telling me that's failing, and it's failing because of the engine tune. Well, if I remove the hyphen, just so that I can ensure that that is where the problem is coming from, and I run it, it's able to run it correctly. But if I bring back that hyphen and I run it, well, now we have an error. So we know that the error is coming from the hyphen itself. Not only is it coming from the hyphen itself, but if this is all considered one string, it's probably failing because of this capital letter as well. Right? It's taking this all in as one word. It's saying, hey, there should be a capital letter in there. So we will have to do something like A through Z as well. And now it's able to take it in and accept the hyphen as well with that uppercase of A through Z from this U in up. Okay, great. Now we got our services table completed. We got our employees. We have a nice comment here. And we have a couple of other tables that we still have to go through. Let's see, we have car services. We have plate. We have a car itself. And then we have the driver. So what we're going to do now is over the next 20 minutes, we're going to break up into our groups. And in those 20 minutes, I would like everyone to go ahead, take this SQL file and add those check constraints, add any sort of descriptions you would like over those 20 minutes. And then we'll reconvene at the 10 o'clock mark, where we'll go over our middle class assignment so that we can get some practical application. I'm going to go ahead and pause the recording here. All right, so we went over how to add comments, but we didn't really cover where those comments exist. So when you add a comment, they actually go into something called PG descriptions. Inside of PG description, there's quite a bit, actually. If we go ahead and go into our car shop, and we run the select query, from PG description. We're going to see that there's a considerable amount of information. But here in description, we see these IOs at first. And as we continue going down, we start seeing, hey, there's something going on here. Well, it turns out that these object OIDs can belong to many different things within Postgres. Some of them are some built-in constraints that we have. Some of them are some built-in arguments that we have. We can see here that there is some join selectivity here of what's going on. But every single one of these commands don't have a name. Instead, they have an object OID. So where does that object OID come from? Well, that object OID comes from another massive table called PG class. So I'm going to go ahead and run a select query from PG class. And now we can see this huge table again, with the very first entry being the OID, and then the second one being the relationship name. So there we see PG static, PG type. If I continue going down, I'm sure we'll run into some other commands. Looks like they're almost all in reference to some of the built-in tables that come in with Postgres as they were installed, from what I can see. But eventually this PG tables go away, and it starts going into the tables that I myself created. Now I don't have time to scroll through all of them, so I need to figure out what it is for my department, right? So I'm going to go ahead and select all from PG class. We haven't covered this where statement yet, so I don't expect anyone to know it. Where relationship name is equal to department. So all I'm telling it to do is find the PG class that has the relationship name of the table that I created, department. Well, when I run this, I can see that I only get one row back. So here's my query. Here's all the different field headers, and these are the entries. So the OID is 1824 for the table department. So now I have that information. My department has the OID of, let's see, OID of 1824. All right, so now that I have that, I also want to see the description for it. Well, where does that description live? We saw that it lives within PG descriptions. So now I can say select all from PG descriptions, where the object OID is equal to 1824. I think that's right. Oh, no, it's 1824.4. Okay, well, now when I run this, I get a syntax error, select all from PG descriptions. I put an S instead of an, made it plural. All right, so now when I run that, I'm able to get my object OID, which is 1824. It tells me the class OID, which is 1250 or 1259. The object sub ID, which is 0 because I don't have one. But then it gives me this description, which is exactly the description that I wrote to make sure that it added. So this should reflect the different departments within the store, i.e. body shop, electrical, etc. Now we're not always going to know where the OID is located. We're not always going to know the OID. And we don't necessarily want to go through this entire process of querying each one of these individually. So what we're going to do is I'm going to write a query that's going to mix them both. I'm going to say select all from PG description, where the object OID is equal to, and I'm going to write another query to select. I only want the OID from PG class, where rel name is equal to department. This is going to return the OID from wherever the relationship department is located, so that this query can then return my description. And let's say that I only wanted to return description. Let's go description. Well, now when I execute this query here, all we're gonna see is the description come back for the table that has the object OID that matches the relationship name of department. And now we should see this should reflect the different departments within the store. Does anyone have any questions over how we can grab the descriptions that we add into individual tables, or how we could familiarize ourselves with these different databases that we've never worked with before? Yeah, I don't see any questions. Oh, I see something in Whiskey questions. I see is the default file format for PG class pipe delimited. Interesting. I'm not sure. Let me check. What do you mean?
I
by-
was just surprised to see the pipes, and so I wasn't sure because usually I thought that was usually comma, but
Are you referencing to this, or are you referencing to the pipe in between?
the ladder, the pipe itself.
Yeah, so almost anything that comes back from SQL, we're gonna see coming back with pipes. And I know it looks weird because everything is formatted kind of yeah, strange because there's so many fields. But if I had my fields, or I had a wider screen to where all these fields can fit nice and neatly one next to another, this would show up pretty well.
Okay.
Over how to compensate for that with the where statements.
Thanks.
Of course. All right. Will, go ahead.
Yeah, so how come we couldn't have done the red class from earlier that you showed us?
One more time, Adrian.
It was remember when you asked ChatGPT how to come up with comments, and it came up with like a double colon red class?
Got it. Yeah, let's try it out. I think I still have that browser open. Let me check it out. So I think you're referencing to this right here, right?
Correct.
Okay, yeah. Let's go ahead and bring it over. Let's plug it in. And let's type in our table department. Okay, so it looks like that command also worked, right? So it was able to select the object description for a department where the relationship, I'm assuming that's what this REG stands for, or actually, I'm not sure what this REG stands for, but I'm assuming that this is for the class that we just queried, which is PG classes. And it was able to take in the name department and find the description for it. It's actually a really good one as well. The reason why I didn't trust this is because I've never seen this commanded before, and I've never utilized it, and I didn't want to just copy and paste it. So it looks like this works really well. I'll have to ask it to break it down so I can learn it, and then I could teach it to everyone. But yeah, this command works. Does that answer your question, or were you just trying to point out that that command also works?
Yeah, it does. Yeah, I didn't know if it worked or not. It just seemed like it was simpler and like, I guess, less verbose than the previous one.
Yeah, definitely. I just need to figure out what's going on under the hood here. I'm assuming it's doing the same exact thing as these two tables, or as these two queries that I just described, but it's all doing it at once in there. I just have to make sure that that's correct. Does that answer your question, Adrian? And DJ, do you have any? I think I can see you putting your mic down. Do you have something you want to add? Oh, okay, cool.
No, that I don't.
Okay. Awesome. All right. If there are no other questions, the next thing we're going to do is we're going to go ahead and take this schema that we were provided here, and we're going to actually draw it out using draw SQL. Right? We're not going to do this together as a class. I want everyone to do it individually. So currently right now it is 10:13. Let's take the next 30 minutes to turn this schema into a draw SQL file so that we can truly understand those relationships, those fields, and what's required out of everything. So currently it's 10:13. Let's come back at 10:45 and continue with part 2 of our lecture. Thank you so much, everyone. I'll see everyone here in 30 minutes. Let's go ahead and continue with part 2 of our lecture. Before continuing with part 2 of our lecture, I actually did a little bit of investigating, I want to call it, over part 1 of that command that we were just talking about. We discovered this command called obj description, and it looks in the department reg class. All right, so obj description goes and actually queries the PG description table, kind of like we do here, where we run the select query from PG description, but instead it's actually just grabbing the description itself, and that is it. But it grabs it from PG descriptions. Now it grabs it from PG descriptions and it expects a class or something that it can cast into an object ID. So this object description is a function that takes in an object ID, right? And all it's doing is that second portion that we discussed. It is running select all from PG description where object ID is equal to the table ID. And here the parameter that's waiting for is something that it can cast into an object ID. Now department is just a string in this case, but this : reg class, what it's actually doing is it's looking at the registered classes that are within SQL. And the registered classes could be tables, they could be databases, they could be fields. All of those will be found when we run this reg class. And what it's looking for is for the exact string as being as a registered class title. And what it actually returns is a special data type. Now, this special data type holds the department itself, as we can see here. I ran select department reg class, and when I ran that, it returns a registered class for the department. Now, this special data type can be casted into an object ID, and that's how this object description works. The object description grabs the object ID from this class that gets returned when it checks the registered classes for department. And that is how this function works. All right, now that we got that out of the way, let's go ahead and continue with part 2 of our lecture. Now, in part 2 of our lecture, what we're going to be going over is going to be SQL queries. And let's actually go ahead and use this little mapping that we have here. We don't want to do this until after the where clause. Perfect. All right, so querying the database. We're going to be covering count, sum, average, aliases, and as. So let me load all of the CSV file here from into my car shop DB. Car is not present in table. Interesting. So it looks like I might have broke something. Let's see. Insert update play violates foreign key constraint. There must have been an error from the very beginning here. Value too long, varying 7. Okay, so it looks like that happened within the driver table. Let me take a look here. 1, 2, 3. So that should be an 8. Okay, so that takes care of that first error. Let's see what other error I ran into. And I apologize, everyone. I should have taken care of this prior to the class coming back. Looks like this violates some sort of name check. So I'm just going to remove that check so that we don't have to worry about it. All right. Okay, so it looks like the problem was my driver itself. Now I got it to work correctly, and I have all of my data. Okay, everything else that we're going to be doing today, we'll be doing it within P-SQL. So I'm going to go ahead and enter my car shop EB. And within there, I'm going to run a simple select query. We've seen this quite a bit of times, but let's actually take a look at it here. So first, let's take a look at our relationships that we have. We can see that we have a car service, a department, a driver, some employees, plates, and services. Well, if I wanted to see all of the different cars that I currently have within my class, I can run something like select all from car. And when I run that, we can see that it grabs all of the fields, all right, all the different fields for my car, which is ID, make, model, year, color. We can see all of those appearing with their independent values for each one of those entries. So I'm grabbing all of the fields from the table car with all of its entries. Okay, that's pretty useful. But at the same time, what if I wanted to do something where I got the count of all of them, right? I just want to see a count of every single one of these cars that I have. Well, I can run something like select count, which is a function. I'm still going to pass the all statement from car. And we'll see that that time it just returns the count for the number of rows, right? The number of rows was 10 because there was 10 entries. Now count only returned one row, but that row belongs to the count of 10. And I can even take this a step further and give it something like sum. Maybe I want to see the sum of something else within my car. So let's say that I have my employees, I have my departments. Well, my employees have salaries. So let's say I want to see what's the sum of all of my employees' salaries, right? Well, first, let's make sure that I can grab the individual field. So I'm going to say select salary. I'm passing one specific field from employee. And we can see that returns the different salaries for each one of them. It's only returning that one field. The field that I specified was salary, so it returns that one unique field. And we get all of these numbers together. Well, now, what happens if I wanted the sum of all of them? It works just like the count statement. Whereas we would put count and close the parentheses, that would return that there is 4 entries. But instead of count, I would actually want to pass in the sum argument. And the sum argument would give me how much money I spend on employee salaries by the end of the year or the end of the month, depending on what it is. I'm pretty sure it's yearly salary. So it looks like in just employee salaries, the shop is spending $220,000, making sure that they get paid appropriately. Okay, so that's count and sum. Well, what if I wanted to see the average? What is the average pay for the employees that currently work within my shop? Well, I can pass in the argument AVG, which stands for average. And when I run that, it tells me that the average salary is $55,000. All right. So we just went over count, sum, average, selecting all, and selecting one specific field. At this point, does anyone have any question over mathematical functions or the select statement? Okay, doesn't seem like there are any questions, so let's start getting into our where clause or as. All right, so currently right now when I select average, it gives me average and then just 55. But that doesn't give me very much detail as to what I'm actually looking at. So what I can do is I can add an alias. I can say as, and by saying as, I'm telling my table what it's going to place as a table header. And let's just say average salary. And now when I run it, instead of just saying average up top, it gives me average salary, which is 55,000. Okay, so there's our as statement there. Now let's go into our where clauses and our mathematical operators as well. So let's say that we want to select, and let's take a look at some other data that takes, let's see, department. Let's take a look at some cars here. Gonna scroll down, find my car table. So here's my car. I have my ID, make, model, year, color, driver, and foreign key. So again, I'm gonna run a clause that says select all from car. Gonna give me all of my information here. We can see that most cars, well, I don't even know what the average of the cars are. So let's go ahead and make them, let's figure out what the average, the middle of the year that the cars were made. So I'm gonna go ahead and say select average year as average year made from car. Okay, so that tells me that most of my cars were made somewhere around the years of 2019. So let's figure out which cars fall before that. How could I do that? Well, I want to select all the information from car where year is less than 2019. Now, when I run that, I get my 3 cars that were made, one in 2018, one in 2017, and one in 2018. All 3 cars are there, and it shows me that information pretty clearly. Okay, awesome. So now I was able to go over my where statement. Maybe I could do something where I'm checking. Let's say we want to check the model, the make and model. So let's say that I want to, again, select all cars. But rather than saying where year is less than, maybe I want to say where year is greater than 2020. That's going to give me all of the years greater than 2020. All of this is evaluating to a true or false variable. That's what it's doing. It's saying where I'm going to check if the current statement or the current entry is greater than 2020. And if this is true, it's part of what it's going to return. But now let's go ahead and take a look at the makes. Let's say where make is in. Let's just go ahead and say Ford. What other things is there? Let's go with Jeep. Oh, we're in. Okay, so there we can see that there's 2 cars, one for each individual make. We have one, which is a Ford F-150, which was made in 2020 and it's red. It belongs to driver 2. And then we have a Jeep Wrangler, which is a 2021, color orange, and it is belongs to driver 9. Okay, I could do something like checking colors. Let's say select car. Oh, sorry, select all from car where color is in red, orange, or let's just say yellow. All the vibrant colors. Let's see what comes back from that. Okay, so it looks like we have 2 red cars, 1 orange car, and no yellow vehicles. So we have our Ford F-150 from the previous query. We have our Jeep Wrangler from the previous query, But now we're adding the Honda Elantra. All right. Okay. So we just went over our where clause and we were over in. Does anyone have any questions over where or the in statement or any of the mathematical operators we just covered? It doesn't seem like there are any questions. So if there are no questions, let's go ahead and run a like statement. And let's do that for our different drivers. Gonna go ahead and take a look at my data here for drivers. Populated in the correct window. Okay, so I have all of these drivers. And I can go ahead and run a like statement to figure out which one of these drivers I want to grab. So for example, if I want to grab something by last name, and what I want to make sure is that I grab anyone who ends with the last name Johnson. Well, I would want to run a query that has like within it. So I would say select all from driver where the name is like, and then from there I can pass in the argument. What is it that I want to look for? Well, I want to look for the last name Johnson. And I think I might have passed in this like statement incorrectly. There we go. There is no is. So I say select all from driver where the name like Johnson. And it was able to grab Michael Johnson, its phone number, the email, and age. So there you go. I was able to run a small query to generate all of the people who end with the last name Johnson. I could also do all of the people that end with son. And that will give me a couple of people. So all I'm doing is by passing the ampersand, the percentage sign at the beginning, all the string that comes after it, it's checking that that is the end of the string. So the same would be vice versa. If I wanted to see what string starts with, so for example, if I want to see all of my drivers who have the first letter of M, I could do M with a percentage sign. That would return Michael Johnson. I don't think I have any repetitive first name letters. So that makes sense. Right, regardless of what I run, we're always going to see repetitive first name letters. I mean, we won't see any repetitive first name letters. Now, let's say I wanted to do something where I wanted to check if a specific string had some sort of another sort of substring. Let me check if I have anything here that has like descriptions within it. Doesn't seem like I do, unfortunately. Okay, well, since I don't have that information, I'm going to go ahead and practice it on my driver. I'm going to check my driver, and what I'm going to do is I'm going to check that there is an @example.com within it. All right, and how I do that, or if I just make sure that there is an @ sign, is I can say select all from driver where email like, and then I can pass in the ampersand at the beginning. Say there should be an @ sign somewhere in here. And then pass in an ampersand at the end. And that's going to check if that ampersand exists anywhere within the string. And I forgot my semicolon. And now if I run that, it returns all of them because all of them have a valid email. So it's matching for that ampersand right in the middle of the string or anywhere within the string. Does anyone have any questions regarding the like statement? Go ahead, Will.
Yeah, is there such a thing as an I like statement?
as an I like statement? I think there is. Let me go ahead and check that out here. I'm gonna get all of the ones that end with son from this statement here. Oh. I think it's name. Okay. And if I run I like, it should give me the, oh, it still gives me the same things. Interesting. Let's see, like with son. Yeah, it looks like the I like statement does exactly the same. The same functionality. Oh, no, it doesn't. Yes, it does. It returns 4 rows and it returns 4 rows and they are the same output. So it looks like I like and like do the same thing. Does that answer your question, Will?
Yeah, it does.
Francisco, sorry for interrupting. Apparently the I like is case insensitive.
Ah, got it. So I like is case insensitive. So if I do something like, oh, well, I guess names wouldn't be a good place to try it out.
If you capitalize your match, it should still match. Capitalize your string after your percent sign. If you capitalize son,
Let's try it out. Perfect. Yeah, thank you. So case insensitive, it doesn't care about casing, it's checking both uppercase and lowercase. Awesome. Yeah, thanks. Appreciate it, DJ. All right. So now we got that like statement out of the way. The next thing we have, we already went over the like statement. Let's see, we went over in as. Okay, the next thing we could look at is going to be limit. And before we go into limit, I'm going to go ahead and add a couple of indexes here. So for example, in here, we already took a look at our driver and we said that we looked at our driver through the name quite a bit of times, right? So let's go ahead and go over the syntax for adding an index and looking at our employees. So before we do that, what I'm going to do here is I'm going to do explain. I think it's explain analyze. Yeah, it is. So let's do explain analyze. Select all from driver where the name is like, and again, let's do the ampersand son. Okay, so when I run this query there, it gives me quite a bit of more information. All right, so it tells me, all right, here is a scan on the driver. Here was my cost, so how long it took. The rows, the width. Here's my actual time. Everything that was filtered, so name was filtered, it was text, and it was filtered to match the ending of son. And then it tells me rows removed from filtered 6, planning time 84 milliseconds, execution time was 42 milliseconds. Okay, so all of that happened in millisecond level. All right, well, below millisecond level, and it worked pretty well. It was able to give me all of my information. If I take off the select analyze, we can see that it returns everything just well. This is just giving me the breakdown of what's actually happening or how long it's taking for this to come back. Well, now let's create an index on the name and see the difference. So I'm going to go ahead and create index, my index name. So I'm going to say IDX driver name. And I have this in the wrong spot. Let me find my driver table. Okay, so here's my driver table. It's dropping if it's being existed, if it already exists, and I'm creating an index for my driver. I'm going to say that it's going to be on the table driver in the field name. That's it. That's all I'm going to be running to create the index. Well, let's actually run this command here. Let's change directory into Postgres 3 and then example. Okay, so there we have our queries, our car shop. Let's write it out. Let's do PSQL car shop DB takes in the car shop SQL. All right, so we see that create index command, and it's telling me, hey, I was able to create an index for the driver, for the name table. Okay, awesome. Can go back to SQL over here. If I run this query, it still works. It still returns to me the same input. But now let's go back to our explain analyze, and let's see what happens when I utilize the index. All right, so let's take a look here. First, we're going to go over the one that we ran without an index. So here's our index. We have 12 rows, the width, actual time happening, and we could see everything that's actually happening where it's being filtered. But here's our planning time, 0.084 milliseconds, and execution time was 0.042 milliseconds. Well, now if we scroll all the way down, we can see our sequence time came through almost exactly the same so far as this 12. Actually, let me make sure. Yep. So this part what came out almost exactly the same. It still filtered and removed 6. Planning time took a little longer, but the execution time was considerably smaller, right? We're at 0.02, whereas before we were at 0.04. We almost cut it in half just by adding an index. And that's where indexes take a role, and we need to ensure that we add them and enforce them so that we could have efficient queries. Again, doesn't really matter with the amount of data that we're working with currently right now, but if we were working with a massive data set, it would be extremely important to have those indexes for efficiency purposes. Will, do you have a question?
No, sorry, that was from earlier.
Okay, awesome. I see a question from Terrence. Did this lesson get moved in the curriculum? No, the lesson should be part 2 within the curriculum. I'll have to address that question after class. I apologize, Terrence. I'll find it for you just in case it's misplaced in some way.
No problem. Thank you.
Of course. All right. So now we were able to go over our indexes. We can see why indexes are important and why it's useful to have them within any field where we're going to commonly utilize the where statement. At this point, does anyone have any questions over indexes, why we need them, or how to add them? Okay, I don't see any questions. I'm going to go ahead and move on here. The next part that we'll be covering will be limit, order by, group by, and the descending argument. Okay, so sticking to drivers, let's go ahead and grab all the drivers. Or actually, let's grab all the cars. So there in car, I can see that I have my make, my models, and my year. It doesn't seem like I have any repetitive values for make. All of them seem to be somewhat unique, even though it wasn't reinforced to be unique. All right, we can have them be repetitive for the entry, but in this case, we don't have any repetitive cars. We're working with each unique car, as it looks like. All right, so if I wanted to see the first car to get through, or I just wanted to see the very first 5 entries, all I would do is pass in my limit argument. So again, I'm going to go and select all from car. But now I'm gonna give it a limit. I'm going to tell it, I only want to see the first 5 entries. And when I run this query here, instead of getting the whole 10 rows, I'm getting the first 5. Okay, so now I have the first 5. What if I wanted to see the last 5? Well, if I wanted to see the last 5, I would need to flip this table upside down. So how could I do that? Well, let's see what happens when we run select all cars with the descending argument. Car descending. It looks like we need a where clause as well in order to get this. Select all from cars. Okay, so that worked. Let's say where year is greater than 2017, so that should only cut 1 car. Okay, so there we see 9 rows were returned, even though there's a total of 10 entries, and it seems like car with the ID of 5 was removed. And now let's say that I wanted to flip this upside down. I would passing descending, or it looks like I'm doing this incorrectly here.
Is it order by
Yeah, I think it was ordered.
before descend? Order by?
You're saying to order by and then descend? It should
Yeah.
syntax error as well. Yeah,
Order by the name and then descend.
I see. So I have to order by first and then I could descend it.
Correct.
Okay, let's see. Perhaps you meant order by part make. That's fair. Let's do. Let's do model. Okay, so now we're able to grab all of the years, and honestly, if I wanted to order it, I might as well order it by the year. That way I could see it. All right, so there you go. We're selecting all the cars from that are greater than 2017, and we're ordering them by the year. So there we can see our Hyundai. We can see that it's starting from smallest to greatest. All right. Well, if I wanted to flip this table upside down, I would just run the descending argument. And then the descending argument would flip the table upside down so that I could see from newest to oldest. Thank you so much, everyone, for the help. I really appreciate that. It looks like we needed the order argument in order to use the descending clause. Okay. Well, now what happens if I wanted to group them? All right. I wanted to use the group by commonality here. So let's say that I have, oh man, what could be grouped efficiently? I could group these by year. Let's do that. Let's say select all from car. And I think I could do group by without any order by here, but I may be wrong. I guess I'll find out here shortly. Car ID must appear in the group by clause or be used in aggregate function. Okay, so it looks like I could get it looks like it's able to group them, right? But because it's grouping them, it can't give me specific details of each one of them. If I wanted to see how many cars were made in each individual year, I could then group them by the year, and I could get back the year as well. So there I can see 1 car was made in 2022, 1 in 2017, 2 in 2018, 2 in 2020, 2 in 2019, and 2 in 2021. All right.
With this group, could you then order them by the year as well?
Yeah, let's go ahead and try that out. Let's say, I think order has to come in before. Let me try that out. Okay, so I can do it this way. I could order by year and it still orders them. And I could also still throw in my descending argument to flip them upside down. All right, that was quite a bit. Does anyone have any questions regarding limit, order by, group by, or descending? If I wanted to run this and place in another limit saying that I only want there to be the last 3 entries, well, now you only get my newest cars from years 2022 to 2020. All right, I'm not seeing any questions populating, and I don't see anything on the whiskey channel. So now let's go over some joins here. I'm actually going to make sure that I reference our lecture this time, just in case, because joins can get very confusing. And the last thing I want to do is complicate things more for us than necessary. All right, so in our join tables, we'll go over left joins, right joins, and we will also cover full joins. So let's concentrate on full joins first. And we can see a direct relationship between our drivers and our cars. So let's try to work through those. So here we have our car, and it has a relationship to a driver. And we can see the actual, there it is. We can see the actual syntax here. All right, we can say that we want to grab things from car and driver, but notice how there's this dot and then star and dot name as driver name, right? Well, we'll cover what that falls into here shortly. So let's say I want to grab all the details from the car that belong to one specific driver. So all I want is the name from the car, the name from the driver, and all the details from the car. So I'm going to grab all from the car. And for now, I'm just going to do name as a placeholder. We'll come back to this here shortly. So I'm grabbing all from the car and name from the driver. Well, now I can specify what table I want to grab them from car. But I also wanted to grab from driver. So I'm going to go ahead and run my join clause. And my join clause is going to specify which table is it that I want to join with. Well, the table that I want to join with is my driver table. And then I have to specify where is the connection. Well, within car, I have this driver as an integer. So I can say car, which is my parent table. And I want to access the field driver dot driver. And that should equal or be the same as my driver ID, right? Because that's what I told it. In my foreign key, I have driver, which is a reference to the driver in .id. Okay. Well, before I run this query, because right now this would return an error, I see that I have driver and I have car up above. Well, oh no, it didn't let me. Okay, this is going to cause an error. I apologize, everyone. Let's see if it lets me traverse now. Okay, good. So now we can see that the error happened, right? We have an error telling me, hey, you're telling me to select star and name, but you're telling me to grab from car. I am telling it to join, but it doesn't know where the star and name is supposed to belong. So I have to specify the table that I wanted to grab from. So I have to say from car, grab all, and from driver, grab name. And I can give it an alias. I can say as driver name. That way it's not confusing. So now I have my select statement here. I'm grabbing car, all the information from the car. I am only grabbing the name from the driver as the driver name. And originally, I'm grabbing from car as my parent table, but I'm joining to the driver where the car.driver field, which is this one, is the same as the driver.id field. Car.driver. Let's see, what didn't you like this time? Car. Go ahead, Brian.
I think it's just the on between join driver and on car.driver.
Have an on somewhere?
I think that's what's missing.
Oh, yeah, thank you. I'm missing the on. Appreciate it. Okay, and now we can see it come through. It grabs all of the individual cars belonging to its driver. Now I can still do a couple of other things, right? We got this specific query. I can grab my car and my driver name. Well, what if I wanted to see how many cars belong to an individual driver? I can still utilize the same query. I just have to add the count. And I believe I can still give it an as alias here. Let's go ahead and say, so now I can see I did a count for the number of cars for the driver name, and I grouped them by the driver name. And we can see that Michael Johnson is the only one that has 2 cars, whereas the remaining of our entries still only have 1 car. All I did was add the count function to the car, and then I grouped my entries by the driver name. Okay, so let's visualize this full join a little bit more here. So now if I grab everything from car and everything from driver, we can see that it all comes back and it's joining them together. It's just showing me one massive table that has all the information of both the cars and name. And that's what we mean by a full join. It's grabbing all the information from both tables and it's merging them where the driver matches the driver ID. All right. Does anyone have any questions regarding joins? Go ahead, Landon.
Yeah, so the join command, it looks like in Postgres defaults to inner joins, which grabs just records from 2 tables that match. And then if you actually do a full join, they'll return all records from both tables, but have null values where your join key is not accurate. So it'll return. So this is technically an inner join.
Got it. Okay, awesome. Thank you. Appreciate it. Yeah, so currently right now it looks like we have an inner join, just like Landon explained, and it's doing that because it's having these matching tables. Whereas a full join, correct me if I'm wrong, Landon, would work regardless of the match. Is that what we're saying?
Yeah, like if you took 2 tables and you did a full join and you wanted to see where records weren't matching and were matching, it would return the data from both tables and show null values. The reason this one doesn't show any differences is because the keys in your cars table and your drivers table, there's only 10 records in each. So it appears like it's doing a full join, but it's actually an inner join. So if you did, like you're adding an extra record, if you change that to a full join, you would see the null records pop up if you did a full join.
All right, let's try it out. So we just restart our database here. I'm gonna run that same command that we had before. We can see there is a total of 10 rows, which is true, right? We also have this 11, which isn't showing. So now instead of running a join, let's run a full join so that we can see it. And now when I run a full join, we can see that we have lines 1 through 9 still matching. And now 11 and 10 don't have anything provided to them. Which is kind of weird. Awesome. All right. Thank you so much, Landon, for that clarification. All right. So now that we have that example, let's go ahead. Oh, go ahead, Kara.
I'm sorry, could you just show the syntax difference there between the full join and the inner join again?
Yeah, of course. Our inner join was just join. And when I ran that, it showed me where there was matches. If I run a full join, all I'm doing is adding full to the left of join. And that shows me all of my drivers and vehicles, regardless whether there were matches or not.
Got it. Perfect. Thank you.
Of course. All right. So next, let's go into left joins. We're still going to utilize the same table, but all we're going to do is we're going to change the syntax here to left join. Let's see what it does here. So it still gives me all of the information because that's all the information I'm asking for. But left join, oh, it looks like Landon just shared it here on the chat, something that explains the left join. What's actually happening on the left join, the table on the right-hand side isn't being joined into anything. It's only the driver table, which is on the left-hand side, that's being joined. Oh, excuse me. It's only the car table, which is on the left-hand side, that's being joined into the driver table on the right. Now, this is just saying that it's loading the entire left side, the entire car table is being loaded, whereas from the right side, only what I'm asking for is being loaded and not being filtered. So in this case, if I wanted something like just the driver name, this would work, and it would be a little bit more efficient than if I were to just try to do an inner join. All right. And the same can be said vice versa. If I wanted to do a right join, which is grabbing everything from the driver table, that's the right, I can grab everything from driver. And let's say from car, all I want is the make. So now instead of loading my entire left table and grabbing all the information from my left table, it's only grabbing the make from the left side, but it's still grabbing all the information from the right side. All right, so the right table is being loaded, all of it automatically, regardless of whether I'm telling it to only grab one field or two fields, it's grabbing all of it. But the left side is only grabbing specifically what I tell it that I need. It's essentially lining up my query set. And that's the difference between the left and the right join. Does anyone have any questions over left, right, inner, and full joins? All right, it seems like there are no questions. So the last thing we're going to go into is joining multiple tables. What if I have 3 tables, right? In this case, the scenario is I want to retrieve a comprehensive detail about cars, their drivers, and their services that they've undergone. So without looking at the actual curriculum, let's go ahead and build this table here. So I want to look. It looks like I'm trying to grab everything from the driver, car, and services. So let's select car dot all, driver dot all, and services, which I believe is just service. Let me take a look here. So is it car service? No. Let's see. So we have a car service. Here we go. Services. Dot R. All right. So we have everything from car, driver, and services. But how do I join them? Well, let's go into joining them from the car table. Let's see. Our services does not have a join over to the car. Let's check out our driver. Our driver does not have a join over to the car. Instead, our car is where the join is referenced to the driver. But then we get this car service down here. So we're going to have to use some many-to-many relationships as well to be able to grab all the information. Okay. So let's get through this. So now we're going to say from car. And then we're going to join. And if I am correct, what I want to join is my driver table. I want to join on where car.driver is equal to driver.id. And then after that, I believe I'm going to run another join right after, where I want to join this multiple services here. And what I'm going to tell it is to match where car service is equal to where the car service is equal to, let's see, car service dot car ID is equal to car dot ID. And I believe I can run that so far. Let's see what that gives us so far. And I'm actually going to take off that on services or the services portion here, just so that I can see it. And run it with car service. Okay, so that gives me all of my ID, make, model for the car, the name, the information about my client, and I can see the service ID and the car ID. Okay, well, I want to grab everything from service, not from service ID. All right. So I'm not completely done yet. Now that we have the service, we should be able to then join with service on where car service dot, and I believe in this case it will be service ID is equal to, and I believe in this case it's services, right? Let me see. Yep, services. So I want to join to services where car service is equal to services.id. Okay, I'm gonna run this query just to make sure it doesn't throw a syntax error. It didn't. And now instead of car service, I want to turn this into services.all. Okay. And now we have the ID, make, model, year, and color of the car, and the driver that it's attached to. We have the ID, name, oh, hello, name, phone, email, age. That's for the driver. And then we have the service ID, the name of the service, and the price for said service. And just like that, we were able to join all three tables to grab all of the information regarding all of the cars of our shop, the drivers that they belong to, and the service that they are currently undergoing. Does anyone have any questions about joining more than three tables? Doesn't look like there are any questions. Does anyone have anything they would like to add? Go ahead, Landon.
Yeah, just like what you were doing there. If the tables are different lengths and you use subsequent joins, it'll continuously shrink your query. So if you have, say you're linking three different tables together and you're using join, 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 if the first join reduces your record count, then the next time you do a join on the next table, it'll reduce it and make the query size smaller. So if you're looking to link like complete all records, like every time, you might use like a different type of join, if that makes any sense. But
Yeah, I understand it. So what we're doing by utilizing the join, we're essentially filtering the output because it's matching those IDs. And each time you join, it's filtering over and over again. But if I were to utilize something like a full join, it would give me all of the records, regardless whether there's a match or not.
exactly.
Perfect. Awesome. Thank you so much for adding that, Lyndon. All right. If there are no questions, the next thing we're going to do is knock into lunch. So I'm going to go ahead and stop our recording here.